Question 25 tells us below are diagnostic test procedures for short to ground circuits. Select one or ones with the S that are correct. When we see that S, that plural, there could be more than one correct answer. So the student that answered this question straight away saw use a multimeter and setting it to ohms can also be a good method of pinpointing a location of a short ground. That's very true, but there's more than one true answer. So let's have a look, okay? Go to the next slide and we'll start with the wiring diagram. The question, I'll go back to the question, sorry. The first thing says, follow a wiring diagram and look at what circuits are being shared on the particular circuit. So with that in view, we'll go to the next slide again. And here we have a wiring diagram. And say, well, let's just pick out something. Here we have some, I think they're ignition coils. Yes, there's 1, 2, 3, 4 ignition coils. And we can see that that ignition coil shares a power that comes along here. Actually, I'll get my pointer. Where's my pointer? Where are we? Here we go. Laser pointer. So we see, that's better. So we see these coils, 1, 2, 3, 4 coils. And we can see that the power comes from a relay here. The relay, which comes off this fusible link, feeds into this circuit when the relay closes, and it will power up down here, but it also comes along, powers up there, powers up there. It keeps coming, and finally we get power to each of our coils. So when our coils are powered up, so are these others. There's a map sensor here that's been powered up, and keeps going, it keeps going. We've got other things here that are powered up. So let's assume all these things are not being powered up. We then know to concentrate in this area. We don't have to worry about any wiring along here. We know we've got a problem in here. But again, we're not looking for a power problem as much as a short problem. So if we have a short problem, we are probably going to disconnect some of these circuits. We want to disconnect this circuit that feeds back here to these solenoids and different things and see if our short is fixed. Or we keep going, we disconnect here and so on. So important that we use our wiring diagram to work out what's feeding off of things so we can do that. I have a method, and I'll just move to the next slide. I have a method where I use a light bulb, such as a headlight bulb, a H4 headlight bulb, and I do that on purpose because it gives me a nice bright light. And obviously when a circuit is shorted, we'll have a blown fuse. So I'll go to that fuse, I will hook up to the feed side of that fuse, which should not be grounded. It should be feeding to the circuit that we're trying to find a problem in. So while it's short to ground, obviously electricity is going to find its easiest path back to ground. So it's going to find an easier path, it will take that path. So why don't we use that path, and it will, if we power up our light bulb on one side, and then on the other side where the ground would normally go, we stick it into the fuse feed, which would normally not light up the bulb when there's no shortage. But while there's a shortage, there's a direct path to ground, that bulb will light up. Sometimes that bulb might not be as bright because it's only a partial short to ground. And, you know, sometimes it can be a very bright light because it's a direct short. But at least we will find our source by having some sort of obvious, and we don't have to use a H4 bulb. We can use a test lamp, or we can use a smaller bulb. I tried to find someone that would do this, that uses the H bulb. I thought it was quite common practice. I learnt this from an auto electrician in Sydney, and I just assumed everyone does this, but apparently not, because I cannot find too many places on the internet that would describe it this way. But what I did find was the next video, which is they use a normal incandescent light bulb, but it's the same. You can do that as well. So we'll look at this video so you can get a feel for that.
And we'll go from there. So the way I like to do it, instead of constantly putting fuses in, is you take a test light and you put it in the fuse location, and so the test light will absorb all of the current flow that's going in and show you that there is a short to ground. So as you can tell at this fuse location, which is fuse 12 on this Jeep Grand Cherokee, there's a short to ground. So the next step you need to do is determine where at on the circuit there is a short to ground. So like I said, fuse 12 is right here. And whenever it comes down, it goes to the power door locks and interior lights, as well as the window switch. So the best way to go about this would be to split the circuit as much as you possibly can to see where at on the circuit it is. So on this fuse, when it comes down, it comes to connector C3, and then it also goes to connector C2 on the fuse box. So what we'll do is we'll disconnect one of those and see if the test light goes out. So I've already diagnosed this, so I'm just going to show you which connector it is. That's C1, that's C2, and then all the way in the back of it is C3. So I'm going to disconnect C3 for you real quick. And the light went out. Now, next step is to break it down by each circuit. So we had pins 6, 7, and 19. So it's, let's see, 6, 7, and 19. Alright, so now the only thing I'm going to do is I'm going to touch the pins. Like I said, it's 6, 7, and 19. So, touch pin 6. My light lights back up. So that means that on pin 6 is my short to ground. So, pin 7. Pin 7, short to ground, is the glove box lamp. Let's go take a look at the glove box lamp. And I've already got it pulled apart, but this is exactly how I found it. The glove box lamp is shorting itself out on the dash frame.
So yeah, that's how we use a method of testing for shorts, and by opening up the different circuits and doing what this gentleman just did. So I hope that helps you to understand, you know, the simplicity of finding a short. Sometimes it's not rocket science. We're trying to bypass the short by unplugging different circuits, or using those circuits to find out which circuit is causing the short, and then we narrow our initial short down to a much smaller area, like it was in this case. All right, we'll move on. So another question was, using your multimeter and setting it to ohms can also be a good method of pinpointing the location of the short to ground. Well, this is correct, and this is what my student answered as being correct. So that was just one of the many correct answers. So yeah, I think we all agree with that, I hope. The ohm meter, again, if we were to touch the ohm meter to the chassis of the car and we have it set to ohms, and we touch it on that terminal that's supposed to feed the current through to activate a device or a circuit, and we will have full ohms or partial ohms if we've got a partial resistance, a partial short. So yeah, it's another way of doing it without the test lamp. But the test lamp is easy because it just sits there and we keep pulling and unplugging things, and we're not moving the connectors around as much. So yeah, it's up to you, but that is another way of finding a short. And I have another method. I used to have a tool like this. I never used it that much. I used to think it wasn't so great, because when you're looking for shorts, it's a device that picks up shorts through a transmitter and a receiver. And the principle of it's good, but when you've got so many different circuits going off in so many different ways, I tended to find it was giving me false direction. But as I saw this video, as you'll see, there's a way of locking the device when you're on the right track to sensitize the device. So maybe I didn't use the equipment correctly. So maybe I'm wrong in my assumption there. But look, I'll let you have a look at this.
The ECT2000 was designed to follow and locate short and open circuits without unnecessarily removing molding, panels, and carpet just to expose the circuit. The smart transmitter has been designed to inject a signal down your circuit. It has a 20-foot power lead and a green signal lead. It also has an open circuit indicator, short grounded circuit indicator, a tone on-off button, and a speaker. In the accessories, you have a blade probe. It's great for fuse terminals and relay terminals. We also have bulb adapters, the wedge-type bulb, and the double terminal, such as the 1157 bulb sockets. And the single-terminal bayonet-style adapter. Bulb adapters are great for connecting the signal to the bulb side of the circuit. A wire-piercing probe, and the back probe. We also have the alligator clip and the universal wire that allows you to solder on any kind of connector you could possibly use. The smart receiver picks up the transmitted signal that the transmitter is sending down the circuit. It picks it up by holding the open and short pickup parallel to your wire. It has a power sensitivity lock button. It has a speaker. It has a direction to short indicators which show you the direction to the short or ground. It has an open circuit indicator which illuminates when the receiver is detecting an open circuit signal. It also has a wire harness probe. It allows you to get into a wire harness that may have a signal that's shielded deep down inside of it. To turn on the receiver, just press the power sensitivity lock button. Here we have a demonstration circuit. We have a positive wire going through the fuse, going into a parallel circuit, going through 3 switches, 3 loads, and back to the negative side of the battery. Right down here, we have a short circuit. We're going to short this demonstration circuit out and see what happens. The first indication of a short circuit is the fact that the circuit doesn't work. To begin looking for the problem, you start at the fuse box itself. Find the bad fuse, remove it, and connect the blade probe adapter to the shorted terminal. Connect the transmitter's power lead to the battery, red clip to positive, black clip to negative. The signal lead is open, so the open circuit indicator is on, and the tone default is off. Connect the signal lead to the blade probe adapter. The short grounded tone is now alerting us that the signal lead, which was open, is now seeing a grounded circuit. To turn the tone off, just press the tone on-off button. The 100 milliamp grounded circuit signal is now transmitting from the circuit that will lead you to the short. Since electricity travels the path of least resistance back to the negative side of the battery, the majority of the short grounded circuit signal is also leading you down to the short. Take the receiver and turn it on. When you first turn on the receiver, it's in pulse mode. The closer you are to the circuit, the more rapid the pulse. The farther away you lift the receiver, the less rapid the pulse becomes. Holding the receiver parallel to your circuit in this direction or flip it in this direction, the direction indicator shows you the direction to the short or ground. Now, we don't advocate tracing the circuit in pulse mode. We'd recommend that you lock the reception sensitivity and then trace the circuit. The reason why we want to lock the reception sensitivity is because these parallel circuits are transmitting signals also that we do not want to trace. We want to ignore those signals. So to do that, hold the receiver close to the strong transmitting signal, press the power sensitivity lock button. Now the weaker signals are ignored. You can now follow the strong grounded circuit signal toward the direction indicators until you lose the signal. Now, turn the smart receivers because maybe the wire took a turn on you. Follow the signal until you lose it again. It's here where you might want to take a closer look at your circuit, so remove whatever's in your way.
Yeah, so that's a pretty neat looking tool. Couple of things. I'm not keen on piercing wires, as you know. Occasionally you do have to, but make sure you use the right electrical liquid to seal it up. You don't use electrical tape because it will not seal up. And if you have a pierced wire, you will be prone to getting moisture. Moisture will cause corrosion, so we don't want that. The other thing that took me was using that spade tool to go into where the fuse was. You're maybe spreading that terminal a little bit, and you end up getting a loose connection there for a bad connection on the fuse. I'd rather do a back probe of that fuse or some other means rather than spreading the terminals like they did in that video. But yeah, when you use it with the sensitivity, I can't remember now if when I was using my tool I did that. Maybe I didn't. And maybe, yeah, wish I had another chance to try it out. But look, it looks magic, doesn't it? But again, you don't need this sort of equipment to find a short. What I told you is okay too. But I guess if you had a short in the middle of a wiring harness, it would maybe give you a chance of finding that short. All right, we'll move on. So to the last question, or the last two questions, none of the above are correct, or all of the above are correct. I'm not allowed to tell you the answer, but I hope that I'll give you some tools to work out the answer. And I think I pretty much have guided you to the right answer now. Thank you.